power to the battery, because this is also going to the resistance. So average power with this branch, that is, so total output, that is 60, and output plus losses, right? Output plus losses. So what are the losses here? Losses in the resistance. So losses in the resistance that we have calculated to 87.4 watt. So 60 divided by 60 plus 287.4, that is the losses in the system. So efficiency, can you calculate the efficiency of this? 60 plus 287.4 and 60 divided by answer. So it's 17 point something. So 17.32%, that is the efficiency of this particular system. So you can see why people are not going to use half wave rectifier. This was the motive to tell all these things, starting from the circuit and the various waveform which we have drawn, and then the calculation of average and RMS value of voltage, then to solve one real time problem, right? If I'm going to have some numbers, how do I get this different values of battery? What are the time which has been taken by the battery to get it fully charged? Now, the last one. So this could be the reason why people are not going with the half wave rectifier, because efficiency is too low. It is too low. Now the sixth part, PIV, peak inverse voltage. So what is peak inverse voltage? By the way, that is Vm plus E, maximum possible voltage. So Vm, how much? 84.85. What is E? E naught, 12. So we can add both these voltages, 96.85 volt, that will appear across the diode while it is not, in conduction. So peak inverse voltage, which we are drawing here in this way. So this is nothing but Vm plus E. If we ignore the negative sign, right here we have ignored the negative sign, otherwise minus 96, that will appear across the diode. Any question, any confusion in this type of exercise, or any confusion related to how do we get, how do we charge the battery from half bridge, if we have taken not bridge, only a single diode if we take into the consideration, half wave, not half bridge. So this can be classified in various parts as well, right? This can be classified if you take the charging system. So this can be classified as a controlled and uncontrolled, I already told you, right? Controlled one and uncontrolled one. Now, how do we classify uncontrolled one? Right. So we have, depending on the type of load which we have connected, half wave, right, full wave, and then we have bridge-based rectifier, bridge rectifier. So half wave, I already told you, only single diode people can utilize. In case of full wave, we can have a center tap and we can use two diodes. So resistance or the load can be connected with the center tap winding, and this would be the basic structure of this particular full wave rectifier. Midpoint, people are also calling it as midpoint rectifier. However, in case of bridge, you can realize most of the chargers, they are using this bridge rectifier instead of single diode or two diode model. People are using, because this two diode model, you can see the current is divided into two parts, as well as this transformer is divided into two parts. And this is very famous for low power application, for flyback converter or some other converter that people are using in case of full wave midpoint converter. So this can be classified in this way. So we can also classify these rectifier depending on the loads. Depending on the loads, because the nature of load could be changed. So uncontrolled rectifier, depending on the load, we can have the R load only, we can have the RL load only, we may have RLC load only, and we may have RLE load as well. So we can take the different combination like RE load as well, right? When we have internal resistance of the battery and one battery pack which is connected to this particular system. So these are the varieties of load which are there, and the performance, waveform, everything will be changed as soon as you are going to change the load. If the value of load is changed, or the parameters from the load side, they are changed, this will be changed. Right? Performance. You may have different input currents in that case. You may have different output voltage in that case. So we need to understand how much voltage and how much current we are drawing for different rectifier. Any question, any discussion which you want in this particular system? Any discussion?
Go back to that previous slide, sir.
Yeah.
Power rating of the system.
Yeah. Do you have confusion in this power rating?
Yes, sir. That's 8.21 amps, sir. How we got
8.21 amps. Yes, that is RMS current, not average. Average one, you can see I naught, that is 5 amps.
That's it. 5 amps, yes.
Anyone else who has any problem in this question? because this question really depicts the charging system and to understand the basic fundamental thing why we are going for any charging system. If you are going for any charging system, you have to follow the fundamentals. What is the VRMS? What is the IRMS current which has been drawn? How much resistance is there? Because you can see, while we are calculating the efficiency, we have considered this resistance as a loss, right? Because in this circuit, this resistance I square R, that are the losses which is occurring in the system. So overall efficiency will be affected very badly due to the heat which or the losses which are produced in the windings or in the circuit. So efficiency of this half wave rectifier is quite low. This is the reason why people are not going for this half wave rectifier. Right. So this is all about the chargers. And one point was mentioned here. That's why I discussed this particular point, because AC charger with no control and communication. So if we go with the basic basic charging system, this way the detailed descriptions I have given for a simple charger. Now 15 amps AC supply with closed loop communication between vehicle and charging current. This type of charger are controlled by battery management system. Here, this charging system, this does not have any kind of battery management system. It is not monitoring. Only they are monitoring the percentage or SOC, we can say, state of charge. If the state of charge is 100%, they will simply, cut off, or the battery will not be charged beyond that particular voltage. That's all. But there are certain advantages to, to control the battery parameter so that the battery should not be overcharged and discharged. And this battery management system that can be integrated. Commonly known as wall-mounted fast AC charger, these also have communication between vehicle and charger. So whatever the type of charger you have, apart from this regular charger means onboard charger. Apart from these, whether we are talking about fast DC-DC charger or wall-mounted charger, fast semi-controlled wall-mounted charger, that is, if I'm not wrong, 22 kilowatt, they does not require, you can see onboard charger of the vehicle and has the capacity to charge the vehicle as fast as 25 minutes. What does it mean? This is a kind of off-board charger, right? Off-board charger. So off-board charger, it is installed at the charging station, right? They have different connectors and pins which are going to charge. So along with the vehicle, we need not to carry any charger. We have off-board charger which is communicating through my battery bank at the vehicle, and after communication, the current starts flowing from one particular point, like from the charger to the battery, and they are monitoring every current, whether I'm operating as a CC, constant current, and then later on it can be changed to CV. So this will be taken care by the BMS. This characteristic is integrated with the BMS. Now, after that, so types of modes of charger. What are the types of and what are the modes of charger? What are the types of modes in charger? We have AC1, household outlet. So this household outlet that is supplying to it 230 volt and 16 amps current, right? Not more than that. So this is the commonly used charger, that is 3.3 kilowatt. Second one, control and communication can be integrated with this charger. So some of the cars, they are coming along with this, where this BMS can be integrated, or control and communication both are there. So this charger will try to communicate with the battery bank as well. Then control and communication, AC charger dedicated EVCS we have, so that is the mod 3, and we have hybrid kind of charger, so we can have the DC as well as AC charging system, and using this control and communication, we are about to, charging in case of mod 4. So there are different modes of chargers. Some of them they have control and communication, some of them are conventional type, they didn't have this BMS or monitoring the battery parameters. So as far as the type of power level in charger is concerned, I already told you the household outlet, that is the level AC level 1 charger. That is AC level 1 charger. And this AC level 1 charger, that is onboard charger, at a rate of around 2.5 kilowatt to 3 kilowatt. So around 3.3 kilowatt charging system is there. Fast AC charger, that is onboard, and some of these fast AC charger, they are also coming with high power rating, starting from 7.7 kilowatt to 22 kilowatt. Level 1 DC charger, so they are categorized in a different category, level 1, level 2, as well as nowadays chargers, they are coming with the level 3 DC charger as well. Level 3 DC charger. So level 3 DC charger beyond 150 kilowatt, like 250 kilowatt or 300 kilowatt, that is the power level for level 3 DC charger. However, if you talk about level 1 DC charger, so level 1 DC charger is 48 volt, 72 volt with power output of 10 kilowatt. Remember, because voltage is very low here, right? 48 volt or hardly 72 volt. So 48 volt we have various vehicle, but for 72 volt in India generally Mahindra Vitario they are running on 72 volt battery. So that's why level 1 DC charger they have manufactured with the 48 volt and 72 volt power output. And the power output, the maximum current which will be drawn here, that is 200 amps in this case. 200 amps. That is the maximum current. Now, if we talk about level 2 charger, then level 2 charger voltage up to 1000 volt with power output of 30 kilowatt and 150 kilowatt. So you can calculate the magnitude of current which we are drawing in case of this charger. In case of, this 150. So if I'm going to calculate the current, because generally in case of DC charger we have P, V into I, cos phi it is not there as it is a DC quantity. So if I wanted to calculate the magnitude of current, magnitude of current, what is the magnitude of current? That is 150 kilowatts suppose, and then we have voltage that is 1000. So these three, 150 ampere. So the advantage. You can see if we talk about the level 1 charger, the constraint is toward the voltage side. We can have 48 volt battery, 72 volt battery, and we have to develop the charger which can supply a current of 200 amps. So you can think about the size of the cable which is required in such scenario. Now at the same time, if you are able to, so in level 2 what they have done, they have only increased the voltage level here. Voltage level here. Because if voltage level is very low, I cannot increase the power level. Because again, you have to increase the magnitude of current. Suppose I'm talking about the 100 kilowatt charger, so this current would may go 2000 amps or more than that. And designing a 2000 ampere cable as compared to 200 ampere, that is quite challenging. So here what they have done, people are trying to reduce the magnitude of current so that the cable size or diameter of the cable can be decreased. So if I'm able to increase the voltage up to 1000 volt, I will get the current which is lesser than the level 1 charger. So you will see level 1 charger connector gun or the size of the cable, it is more as compared to level 2 DC charger. This is the biggest advantage, right? So AC charger that can be classified here. That can be classified, right? AC chargers, normal one or how.
ਤੇ ਤੂੰ ਕਦੋਂ ਕਦੋਂ ਆਵਾਜ਼ ਦੇ ਦੇ ਕਰ ਮੈਂ ਕੱਲੀ ਰਹਿਣੀ ਆ ਮੈਂ ਕਿਹਾ ਇਹਦਾ ਗੇਟ ਖੁੱਲਿਆ ਨਹੀਂ ਹੋਇਆ ਸੀ ਉਹ ਹੁਣ ਲੱਗ ਕੇ